Hey guys, this is Rob. Welcome to another Revit electrical video. In this one, we're going to cover how to take an existing normal power system and add a generator, a dual source transfer switch, and an emergency panel, and get those all documented in a single line diagram and in your actual model, logically connected so that loads show up everywhere you want them to. So let's dig right in. So right now I'm in a small little project I set up for demo purposes to show how this works. I'm going to show you how to get a transfer switch and emergency panel installed into your project when right now you don't have one. So sometimes this happens early in the project. You don't need an emergency panel, and then later on you decide, well, we're going to add a generator, we're going to add a transfer switch and all that stuff. So I'm just going to show you the process that we use to get that installed in an existing project. So what I have here is just a small little area of the parking garage level. And this project, by the way, this background architectural is one that Autodesk supplies. And so I'm going to be doing a full tutorial on how to set a whole project up with this. But for now, we're looking at this little piece of it. We've got a main distribution board, MDB, down here in the utility room. And it happens to feed a house distribution board, HDB. And as you can see, I have just a couple of receptacle circuits. I've got one here to circuit 1, one here to circuit 3. And then on my lighting plan for this same area, I have a circuit of lighting to the house distribution board on circuit 2. And from the stairway, I have a lighting circuit to HDB4. Now let's look at the panel schedules for these, which are set up. Let's look at HDB. And as you can see, I've arranged them with receptacles down the left. So receptacle electrical room, receptacle parking. And then over here we have the lights in the utility and lights in the stairs. Simple little 4-circuit job. So if we look further, the main distribution board only serves the house distribution board like this. And let's look at the one-line diagram, single-line diagram, which really shows the topology of this. We have a main distribution board here, simple 225 amp breaker that feeds the house distribution board. That is very cut and dry simple. So what we want to do, let's say in this project, is now we decide we're going to add a generator with its automatic transfer switch, and we want a separate E-panel, emergency panel. We want to move some of the loads, maybe some of the emergency lights, maybe some emergency receptacles over to this E-panel. So how do we do that? Well, first let's set up our diagram so that we can, see what the end result looks like logically. Now, in other videos, and I'm going to point to some videos up above in the cards, I show how I draw these one-line diagrams, single-line diagrams, because I've had to create my own custom families for all of these symbols. Revit does not come with any of these. And so I've shown how I do that. So what I've got is I've got just a sample view, if you will, drafting view of most of the symbols that we end up using. So I don't need to actually drag them in from the system button or from the project browser. So I'm just going to drag them in from here, or I can create from here. So what I need to do is, this guy's my generator. So I'm going to right click and say create similar, pop over to my single line, and let's get that generator over here somewhere. What else do I need? I'm going to need a transfer switch right there. So let's create similar. And this is a good way to kind of have a library of your symbols that you can just create similar from. That's one little tip here. I'm going to put that guy here. And then I also need a panel. We can just create similar from here, just a main lug only panel. And I'm running out of room, so I'm going to move this around a little bit. Get that up there. And get this guy. We'll arrange it in a minute. This is going to be panel. And we'll just call it simply panel E. Nothing fancy here. And then I like to, instead of normal, I like to go ahead and put a utility feed, and then this is the generator feed. Now this all assumes you have some basic electrical distribution knowledge and how this works. The utility feeds one side of this transfer switch. The generator or backup source feeds the other side of the transfer switch. And this little guy here is the switch that goes back and forth. It'll either be left or it will tilt to the right. And let me see if I can draw that in here. Annotate a detail line, and this would switch over to this stage. when it's in generator mode. And then of course this all feeds the panel E. And let me get to my proper medium lines to finish this off. Draw that there to there, and this is just a dumb diagram. There's nothing smart here. So we will get this moved down. And then we need a source, utility source. Now, it depends on the load we have on this panel E. Let's assume right now that we're only going to have a 100 amp panel. Now, I could subfeed it from this house distribution board, because in reality, I haven't shown everything. I haven't shown the metering and such, but a lot of times this house distribution board will be on its own meter. And so if I went to an emergency feed here, it would need another meter. So I'm going to take it out of the house distribution board for now. Now, what I have done for this is I have created a small little breaker, this little guy here, that actually fits inside of a panel board. So diagrammatically, it shows me coming out of there. So let me go create similar for this medium line, come across, and I'll do a little jog in this guy and get it over there. Yeah, close. So now I have the actual diagram. We got power flow comes up through this breaker, through the transfer switch down to panel E. Or if we are transferred over, this guy would be gone. And we have power flow from the generator through the transfer switch down to panel E. Get rid of that. And I need to modify this. And this will all be set up for whatever size generator. I'm not doing a sizing exercise here. So we will say this is going to be like, again, these are all just hypothetical numbers right now, to show the intent of how to actually implement this in Revit and get it all logically connected. Hey, and if you find this information useful, I'd love it if you hit that like button down below to help propagate it to others. And if you want to stick around for more electrical only Revit videos, please hit subscribe and even leave a comment if you like. Appreciate that. Thanks so much. Now, I'll point out right now that the out-of-the-box transfer switch that comes with Revit only allows one source of connection, only one upstream. So you can only connect this panel E, for example, to the HDB, not to the generator. Now, why does that matter? Well, we like to use this panel and switchboard and even the generator as a load summary. We like to have all the loads show up on those. Like I say, just like MDB, it shows all the loads in the building right now, which are not very many, but it shows them classified by loads. Lighting is separate, receptacle is separate. It applies the proper demand factor and gives us the total load. I would love this kind of load summary, if you will, for the generator itself, so I can determine what's the load on my generator. Now, workarounds that we've done before we had a two-source transfer switch in Revit was to assume that was to just go with, well, panel E is the same load that's going to be on this generator. That may be true most of the time, but there's other times when this generator feeds multiple panels. In a larger building, this generator may feed its own generator distribution system, which then feeds a life safety panel, also feeds a legally required standby panel for elevators and such. So there's a number of examples where I really do need this generator to be its own load summary. Also, sometimes there are loads that are on the house system, but they turn off by load shedding when I'm on the generator. So in a number of scenarios where I really need this generator to have its own load summary. So we'll show you how we can do that. So that is the basic single line diagram for this, and we're going to use this to develop our model now. So let's jump back into our actual electrical model. A lot of these are customized families, which I cover. I'll point to some other videos above. But right now, let's get some pieces into this. We need a generator and we need a transfer switch. So down here in my families, I've already brought in a bunch of custom families. Let me see if I can find a generator. For this one, I can actually show you how I insert a generator from Autodesk. Up here, if you go under Insert, load Autodesk family, a little cloud there. So Autodesk has a number of built-in families, and I've covered those again in another video. But if we go to electrical, they have architectural, which we do not want because these do not have electrical connections. So stay away from the architectural. Go down to MEP. There's connectors, power. So here's generation and transformers. So we can go to a diesel emergency. Let's go to that. Diesel emergency generator. Say load that. And it'll download that into your project. Now over here under electrical equipment, there it is. And it's got pretty big sizes. But we're just going to bring in one of these for now and at least get it in here. Now what we're going to say is, this has not been set up yet, but we're going to say in this parking garage that the architect has decided they're going to turn this parking stall area into a generator room. They're going to apply the proper HVAC systems to get air in and exhaust out and venting and all of that. So we're just going to say for demonstration purposes that it's going to go in here. Now I put that, it's just a box right now, so we can just show that anywhere in here. I'll put that right there. Now what we have on this is we have a power connector. Now, one thing that I've emphasized in my power distribution review, another video above, is that the power button connects upstream. It always is connecting upstream. So if you go to the single line diagram, the generator is the top of this stream, if you will, top of the power. It is a source. So power flows away from it. There's no further connection to this generator above. So the generator is, so long story short, we're not going to need to connect this generator to a power source because it is a power source. So we ignore the power button. We do need to connect the downstream devices to this. So what's a downstream device? Well, the first downstream device is this transfer switch. And let me put a label on this because eventually we're going to label things like this. I'm just going to call it ATS right now. And we'll call this Gen. Some simple labeling. Again, this is not a complete diagram, just get the point across. So let's get the transfer switch in there. Now, again, I've had to customize the transfer switch because the one from Revit only has a single source. And as we can tell, this guy has a source of power from utility upstream and a source of power from the generator. If we don't connect both sources, we won't get both load summaries. So let us bring in that transfer switch. It's under electrical equipment. It's under automatic transfer switch, little 100 amp guy. And we're going to put the transfer switch, we're going to put that here in this generator room. And this rotates around the back right there. So this is the ATS, and we're going to call it panel name ATS. And we're going to tag it by category up here at the top. ATS. Good. And this guy is going to be called, he has a panel name as well. Panel name Gen. And let's tag that as Gen. Simple as that. So there's that piece. Now the other piece we need is our panel E. So let's get the panel E. We're going to put that in here also. This will become an emergency room. So let's go down. We can either go down to our panels, 208 main lug only, 100 amp, drag that in. Place that right next to the automatic transfer switch. Let's give it its name, panel E, simple as that. And tag category, panel E. So now we have all of our pieces. Now we need to connect them together. So you can start however you like. You can start at the bottom, work your way up. I kind of like to start at the top and then take the next one up, things like that. Sometimes because mainly when you run into transformers, you'll find you have to tweak some things before you can connect a downstream device. Just a habit I got into. So what I'm going to do for demonstration purposes is just connect the transfer switch to its utility source and then the panel E to that to show the out-of-the-box method. So the transfer switch, if I hit power, I'm going upstream, you'll see I get two. So connector one, power, utility power. I want to connect this utility power to what? That goes upstream to panel HDB. Now I can just click on HDB or I can find it up here. Now one thing you'll notice is that I can only connect to the generator. I can't connect anything else. What's going on? Well, this is a good example of what can happen with voltages and defaults, because it's only going to show me the panels that I can actually connect to. So what's going on here? Well, first of all, let's look at our generator. Let's look at its setup here. 200 kW. So out of the box, this guy is set up at 480. So we need to change that. Let us go to the edit type, and we're going to change this to a 208. And we can simply type in 208 here under alternator voltage. Okay, now it's set up as 12208 distribution. So good, that checks out. Now what about the ATS? What voltage is it set up? It is also set up at 480, and so we need to edit its type and go to 208. Now if you needed both voltages of generators and transformers for some reason, you would have to create separate types, duplicate and make types, because this voltage is a type parameter. But in our case, we're fine doing this. Now we should be able to find and connect what we want to. So let's go back up. Now you already connected it. You can just go up to electrical circuits and change it. Now you can see we have all of our 208 distributions showing up in our selection. So we want to connect that transfer switch to the house distribution board. It's connected now, and it's showing a little blue arrow towards it. So that's good, and I'm going to escape out of that. I don't typically show a home run on the electrical equipment. So the ATS is connected. And one more thing I'll jump in here is to show you how you can see what's connected logically using. I have a whole video on the system browser, but let's go to view, and over here on the right, user interface, and there's one called system browser. Click on that, opens up this little window. And this is a handy tool to see what you've got. This is all systems. We're going to go to we don't want analytical systems. We do want systems, but we do want under electrical. If you start doing all of this, you will see what you have. It's in a form that shows how things are connected. It's indented. So it shows that we have the ATS. There's one unconnected connection, which is that second source we haven't dealt with. But down on the main distribution board on circuit 1, we have the house distribution board. And under the HDB, we've got a bunch of receptacles, a bunch of lights. Circuit 3 is receptacles. Circuit 4 is some other stuff. But mainly what we want is down here, the ATS. So the ATS is upstream, connected upstream to the house distribution board. We can also see that here. ATS with a 3-pole breaker. And let's just say I want to move that guy down to the bottom. Okay, and we can change its breaker and all that. We can do it while we're in here right now. Okay, and it has no load on it right now because we do not have a panel connected to the ATS. Now the main distribution board is still the same. We haven't changed any of that. But this system browser will just help you realize how things are connected if you want to verify that it's connected properly. So let us go now to the next step, and I'm going to close this guy for now so we can see all these diagrams. So we've got this connected here. Now we need to connect this E to the transfer switch upstream. So panel E, we want to power it up upstream to the ATS. Find it on your list, or you can simply select panel, and then you can find it in your plan view and click on it. That's the same thing as finding it in the dropdown. Now you can see it's connected to ATS. It's connected to circuit 1 on the ATS. Now we have no load on panel E, and let's go ahead and create a panel schedule for this. So let's go to Analyze, Panel Schedules, and you'll see that it wants to create panel schedules for everything. Now, I don't need one for the ATS. It's typically going to be the same load as the panel it feeds. So I don't actually need one for that, but let's do one for E and for the generator. Now I have those panel schedules created and added to my list of panel schedules. So let's look at panel E, which is already open. There's no loads on it. Generator, no loads on that. So we have E connected to ATS, connected to HDB. Let's start adding load to panel E. Now I've already got a receptacle here in the generator, what's going to be the generator room. So let's go ahead and move that from HDB. Let's move it over to panel E. Well, there's a simple way to do that. If you hover over a device, or they call it a fixture, that's on that circuit, hit tab once and it'll highlight every piece, and then tab again, and you'll typically get this little dashed box, and then it'll say electric circuits. Click on that. Now I've highlighted the electrical circuit over here in the properties, and I can see everything going on that. I can also up top get to, well, what panel is that connected to? Right now, this receptacle circuit is connected to panel HDB. I want to change that, and I can select the panel here. And since they're all close, let's just do it that way. Select the panel and change it from there to panel E. Now it's on panel E. Simple as that. The tag, which is smart, changes it to panel E. And we can actually go look at panel schedule E. There it is. So we've got load, not much, load on panel E. Now also, we should be seeing that load still on HDB. And it's still in there, but it took the actual circuit off of here. The load is coming through the ATS, which you can see down here on phase C. All the loads now are all sent over via the ATS. Okay, so let's go back here, and we want to switch now this utility room also. Let's say we want the utility room on emergency power as well. Well, again, hover over any receptacle on this circuit, hit tab usually twice, click it. Now we're modifying the circuit. We can change it, and this way I'll do it with the drop down, change it also to panel E. Automatically changes this. It wants to redraw that there. So we can say arc, and then I can get rid of this one and let it use this one. Home run, retag it. I can move it out of this mess of stairs so it's readable. Now these are hooked to panel E3. We can verify that by going to panel E. Again, the HDB shows it on the ATS. So it's moving all of those loads over. Now, same thing with lighting. Let's go over to lighting. I've got the panels and such shown here. I'm going to go ahead and label these on my lighting plan as well. And it's easy to do with tag by category. There's no text involved here. We want to move these stair lights to the E panel. Again, hover over a light, hover over, there we go, and click it, and then move it to panel E. Voila, and it wants to redraw the home run, which we'll let it do. I like to let it do the natural home runs wherever it wants to. Makes life easier later if I'm moving things around. So let's retag E5. And then finally, I'm going to put all these utility lights on to panel E as well. Hover over it, click it, change it to panel E, like that, new home run. So this is ends up also being somewhat of a circuiting tutorial, which never hurts to practice. So there, I have those all in the emergency. And here they are, and I can move these around. I'm going to move this across and then move it up. Same with this one. Move across and then move it up. So easy to move things on panel schedules. Okay. They're different order. So now I have all those. So here, generator has no load on it. Now, one thing I also want to bring up here, and this is getting picky, I know. I don't want my generator schedule to look like a panel schedule. I want it to look more like my main distribution board, which I've customized to only show the load. I don't show the breaker and frame here because I want to let my single line diagram indicate those details, and I don't want to duplicate them here. I just want this to show connections and loads. So how can I change the generator from a panel to be a switchboard? I can't do it here. I have to actually edit that family. So it's a little advanced, but I'm going to show you quickly how to do that so that if you run into the same situation where you really don't want a panel board, you want a switchboard type of schedule. So in my generator, and you can skip this if you don't mind the way it is, you can go up to Edit Family. And here's this generator, and it's got these squares are conduit connections, and the circle is the electrical connector. But what I can do is up here in the top left, there's a family category and parameters. This is where it is set up when it was created to be electrical equipment, which is correct. And then down here under family parameters, there is a further definition of what kind of part is it. Right there, it's a panel board. I can simply change that to a switchboard. And that domino effects into letting us use a switchboard type of schedule. So, okay. And I'm going to load this to my project. I'm not going to save this right now. In the future, I should probably create a custom generator that has that. But for now, I'm not going to save it. This means I'm not going to save it as a separate family. I don't need it, but I do want to load it into my project and overwrite what I have here now. So now this is the same old generator, but look at the schedule. Automatically now we are in switchboard schedule. So that's just a little pro tip for you if you want to switch from panelboard to switchboard type of equipment. So there we go. And there's no loads on this generator. Well, how can we get loads on the generator? Well, we need to get this other connection from the transfer switch so that the loads on panel E get propagated to the generator. So back here, here's our ATS. Recall that it had two connections. Now it doesn't give us the power button anymore. So how are we going to connect the second electrical connection? It gets a little tricky. What we need to do is there's a system selector box, and you can see that this is all of the circuits that are on it. Now, I wish this told you which ones were source and which ones were downstream. Well, in this case, the unnamed one happens to be the other upstream that we haven't connected yet. So click on unnamed. Now we want to connect that to the generator. Select panel, and in this case, panel switchboard is the same thing. Connect on the generator. Now the ATS is connected to the generator. And if we go look at the generator, there it is. Automatically ATS is there. The load from panel E. And so what I would do here is I would typically go E and via the ATS just to clarify. So now all of my loads on E are shown on the generator as well as panel E. You can see these are all the same. And the ATS is shown here. And I can again show E via the ATS. That way I have all of my loads shown on all of my panels, and I can even create a panel schedule sheet, which I think is helpful to see them all in one place. And I don't have one set up, but let's just put it on the detail sheet for now. We're going to drag all of these panels in. We've got the MDB first, and then we're going to have the HDB. And then let's drag our panel E. And our generator. Now we have them all together, and we can see that the load, total demand 1200, and this is all going back to the MDB. We have panel E, and we have the generator. All of these are shown and connected logically, just like our single line diagram, and we have load summaries for everything. So hopefully that helps show how that works, how you can insert a generator and a transfer switch and emergency panel into your project and get loads transferred over and connected properly and show up on multiple load summaries because of that two-source transfer switch. Until next time.